Hello, physics students. This is Mr. Pham, and this is the start of your physics videos for the next, I don't know, till the end of school. So I wanted to start this video with how I'm going to teach you over the next 3, 4, maybe 5, or maybe till the end of the school year, um, how I'm going to do the videos, my expectations, and the assignments that you're going to get. So, uh, first of all, if you ever need to meet with me, I will have a Google Hangout. My virtual office hours every day, Monday through Friday, is going to be between 11 and 12. If you need to contact me, you can contact me through Facebook. You can meet up with me through Google Hangouts, or you can download the Zoom app and Zoom with me, which is my preferred method of face-to-face contact at the moment. But Google Hangouts is always an option. Email is as well. You can contact me through Remind 101. I'm even going to post, I hate doing this, but I'm going to post my personal phone number so you can send me a text message if necessary. But there is a number of different ways for you to contact me. The way this is going to work is all teachers are supposed to post at least a 10-minute video on our YouTube channel. We should have 5 videos a week, so you should get at least 50 minutes of this face right here, instruction, posted on my YouTube channel, which is Robert Pham. The background is Professor Snape with a little quote. That's my YouTube banner. But all of my videos will be posted on YouTube. I will also post my videos on Facebook. They will be posted on Google Classroom on our physics page. If you do not have internet access, and first of all, like, how are you watching this if you don't have internet access? But if you don't have internet access, you can go up to the school Monday and receive a thumb drive with all of the assignments and videos for your teachers. Ms. Cochran or Brandy Miller will be able to put all of that information on a 16 gigabyte thumb drive, and you can access all of that stuff on your Chromebooks. So they'll also give you print copies of the notes if you need it. I'll have those ready on my drive, that's just shared drive that they're going to pull from. I'll have all the assignments as well, but there really is no excuse to not being able to see the information, see the videos, or do the assignments. And I'm going to, because we are in this weird situation, I'm going to make this class easier than it already has been. But we're going to take things slowly. So all of my videos will be recorded on Zoom. I will be able to display my notes on Zoom. I will even be able to display animations. And if you have internet access, a Chromebook or a computer at home, you should be able to use any of those animations if you need to. I'll post links to what it is. But that is the way it's going to be. Um, so I want to go ahead and get started. Currently, you just see me as a big screen, but I can share my screen. Let me get this out of the way, and let me do, whoops, this right here. So what you should be seeing right now are my notes, which is done on that crappy program that no one likes, I know. But so we're going to be talking about electricity. We are going to look at circuits, something called potential difference. You're going to figure out what voltage is, how electricity flows. We're even going to talk about gravity. But to uh, to before we cover any of this, we kind of need to cover a concept that we talked about uh, the first semester, which is force. So here we go. We're going to talk about force. You should know by now, oh, it's changing colors, that force is equal to mass times acceleration. This should be known to you. And just looked at my wife. So what I'm going to show you is one of the animations that I have set up. So it's going to take me a moment. Yeah, you're going to see me, there we go, doing this. So what I have here is, should still be seeing it. Let's make sure, stop share. Let's do this again. And there we go. All right, so what you should see is an animation of a little wooden guy here. He's gonna push this block. And what I want you to notice are the different forces that are currently being applied to that box. Now, the person's not pushing it, but there are two forces being applied to that box right now. And these are forces that you should be familiar with. One is the normal force. The normal force is the force of the ground being applied to the box. The box applies a force to the ground, and the ground applies an equal but opposite force to the box. Now, how do I know that it's equal but opposite? Well, one, it's equal because the box is not currently flying up into the air. If the force of being applied by the ground was not equal, it was in fact greater, then that box would spring upwards. So it is equal, and it is opposite because the box is being pressed down while the ground is pressing up. So what is that force that's pushing down on that box? Well, it's gravity, and that's designated by the Fg here. The Fg says that is the force of gravity. That's important because we're going to be looking at gravity. I close my timer. I need to make sure I stay within the 10 minutes. I'm going to try and make these videos short as possible. I'm not going to cover a lot of content, and plus, by shortening the videos and not covering as much and covering things very slowly, I can make videos pretty quickly. Anyway, so I got the force of gravity being applied by the box. Now, the gravity, of course, assuming this is Earth, which is this is what the little thing is showing me, has a acceleration of 9.8 meters per second squared. So you should know that by now. Well, right now the box is not moving. It's not moving up. It's not moving down. All forces are equal. But what were to happen if I were to push on the box? All right, so little guy here is going to push, and right now he's applying a force of 22 newtons. Now, is the box moving? No, it is not moving. And why is it not moving? It's because the force of friction, the frictional force, is pressing opposite of what the guy is doing right now, or girl, could be a girl, but he's applying a force to they are applying, let's use a gender neutral pronoun. They are applying a force to the right, but friction is applying a force to the left. And because of the box's weight, it has a mass of 100 kilograms, and if you wanted to find the weight of that object, you would take the mass times acceleration due to gravity, which would be 980 newtons of force. Well, he's not overcoming that. He's not overcoming the gravity, force of gravity. He's not overcoming the force of friction. So he has to push, push, push until eventually, as he increases his force, still not there, still not there, he may, still not moving, still not moving. Oh, there he goes. Once he applied an appropriate amount of force, the box moved. And that was right around 200, I think. Or was it a little bit higher? It's kind of hard to do this with a mouse. Nope, it's not that, not that, not that. But right here, around 480. So he had to apply a force of 480 newtons to get that object to move, because he had to overcome the forces of gravity and the frictional force that's pushing in the opposite direction. So force is equal to mass times acceleration, as you should know. But what were to happen if we were to put him on Jupiter, which has a tremendous force of gravity? What do you think must the applied force be? Is it going to be higher or lower than the 480 newtons that he had to apply to get the object to move? He's on Earth, 9.8 meters per second squared. Now he's on Jupiter, the force acceleration due to gravity is 24.7 meters per second squared. Let's see what happens. Let's just go ahead and apply. Well, I can even add Let's go 480. Nope, that's not it. About 490. Nope, that's not it. All right, well, what about 500? Nope, still not moving. So what we're going to have to do is we have to keep on inputting more and more force. And as you can see, the box is still not moving. 700, let's go 980. Nope, still not moving because the force of due to gravity is so great because Jupiter's gravity is so great, it's going to take more and more. So let's go to 1500. Oh, now he's moving. Oh, crash. I don't know if you could hear that or not. So what you should see is that there was a lower force of gravity on Earth compared to the force due to gravity on Jupiter. And then that should be able to tell you what happens then on the moon. So your assignment for this day, which will be March 30th, you are to make a prediction on what would happen to the amount of force that the person would need to apply to move the box. It's a simple assignment. I'm going to post that on a Google form, and all you have to do is type in your answer, or if you want to, you can print the paper off and write your answer on that and turn that in. The way assignments are going to work is that each assignment, and they're going to be short assignments, is going to be my way of knowing that you were in school. And since you were in school, you get attendance for that. So you have to do the assignment. If we're only out for 3 weeks, and I'm not counting the first week that we were out, but for the remainder of this time before maybe April 17th when we come back, each assignment is your day's attendance. So you have to do it. Now you'll have 3 days to get it done after we come back. And if you don't get it done, then those count as absences. So I will post the assignment on Google Classroom. I will post the assignment on the Google Drive there, and then which can be transferred to the USB. You can simply just type it in and then submit it through Google Classroom. There's going to be really no reason for you not to do this or have access to these assignments, but that will be your assignment. I want you to make a logical prediction and then explain why that prediction is your prediction on the moving the box. Like what would happen if the person, and the box were on the moon? What do you think would happen to the applied force to get that box to move? All right, so that is the first lesson for this week. You're going to notice that I'm going to be wearing this same shirt because I'm filming all of these on one day. But just pretend that I'm really poor and I only have one shirt. So I have to wear the same shirt every day. All right, so I will see you tomorrow. Hope you guys are having some kind of enjoyment. If you ever need me, please let me know. Joey Kid, I do not want you to send me 1,000 emails from everything that you've seen on the internet. All right, so I'm going to talk to you later. Take care.